Assalamualaikum warahmatullahi wabarakatuh and good evening to lecturer and student. We are from group 6. Uh, we will present about the finding for the lab 5 Pelton wheel turbine. So for the lab, we divided each of our members with tasks. For the chapter 1 introduction is me Muhammad Izzuddin bin Jamal Abdul Nasir, and for the chapter 2 and chapter 5 the theory and conclusion is made by Badrul Amin bin Badrul Hisham, and for the procedure of the experiment is Nur Iman Balkis binti Syamsul Kamar, and for the group for the result discussion and graph is made by Hani Brenda Duni, anak Winston Rajid, and Nurul Amira binti Muhammad Nasir. Right, we will start our presentation. My name is Muhammad Izzuddin bin Jamal Abdul Nasir. My metric number is MA19209. So, for the first presentation, I will talk about the abstract for the Pelton wheel lab. The finding of an experiment carried out to study the properties and performance of a Pelton wheel are herein discussed with much emphasis placed on the output measure. The resulting output was discussed against the theoretical output to determine reasons and causes of a deviation. Results were presented in a graph, and the properties of the graph used to discuss the properties of the turbine under study. Flow was varied and her head measured against each variance to indicate the power of the system. The parameter needed for the study were also measured and implemented for the study. The potential under study was a smaller scale, though it acted as representative of a similar system in a bigger scale. The introduction about the Pelton wheel turbine. So, firstly, the Pelton wheel turbine is an impulsive type of turbine invented by American inventor Lester Alan Pelton in the 1870s. A Pelton turbine or a Pelton wheel is a type of hydro turbine, specifically an impulse turbine used frequently in hydroelectric plants. A tangential flow impulse turbine in which the pressure energy of water is transformed to a kinetic energy from a high speed of water jet that strikes the wheel tangentially to make it turn around. Next, the part and the function. So, firstly, about the bucket. The buckets are made by two hemispherical balls joined together, and each of the bucket has a small wall in the between two hemispherical balls. That is called splitter. Here is the splitter. The splitter is to split the water strike to equal equal part of the cup. Secondly is the runner. The runner is a rotating part of the turbine. It is a circular disc on the periphery of which a number of buckets evenly spaced are fixed. Here is the runner. The number of buckets is separate fixed space. The third part is the casing. It is to prevent the splashing of the water and help to discharge the water to the terrace. It's also for the safety for a user to avoid the water splash. The casing is made from steel for better strength. The branch part is to supply water to the nozzle. The last part is the nozzle. The purpose of the nozzle is to increase the kinetic energy of the water that is going to strike the bucket or the vent linked to the runner. So there is a sphere in the nozzle to regulate the flow of the water. So if the the spear is like a needle, conical needle. If the spear is move backward, the flow rate of the water will increase. If the nozzle is pushed forward, the flow rate of the water will decrease. Okay, principle for the Pelton wheel turbine. So firstly, the water is stored at the height head, and then from the penstock, the water goes to the nozzle. For the nozzle, the spear control the flow rate of the water. The spear is pushed backward, so the flow rate of the water increase. So the kinetic energy of the water increase, it form a water jet. So from the water jet, strike the bucket or veins. The water hit the vein with constant velocity. So the movement of the vein will be the same because of the water hit the vein with the same flow rate. It's because of the efficiency is higher for the Pelton wheel turbine for about 95%. So for the penstock, to the nozzle, spear control the flow rate, jet of water hit the vein, and the runner is rotating. So from the runner rotating, from the kinetic energy, it convert to the electrical energy power. Right, that's all. The casing is to protect from the water to hit outside. So the pattern wheel is safe.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day. Today I will present the experiment called lab Pelton wheel turbine, and I will present about the introduction and a bit of theory for this experiment. First of all, this is a Pelton wind turbine. As we can see here, the figure show a setup for the experiment. This is the setup that we have a Pelton turbine and a jet here, where is the water flowing out and push the bucket. Okay, this Pelton will turbine designed with a bucket turbine, or the propeller have the bucket design, which is it can split the water flow out into half, and it will determine of the speed of the water flow and how fast the propeller is rotate, and we can analyze this the power output of the turbine by using the Euler equation. Okay, and then we see this is a Pelton wheel on schematic diagram. Here we can see there is a penstock where the water flow from the source, and we have the runner and also the shaft, and the propeller is designed in bucket. So the water will flow out from the jet and there is a spear which is we can adjust the area of the water flowing throughout this jet and push the bucket. Okay, and this is the casing. Okay, and we also can define from the equation and get the size of the bucket. So this is the view from bottom of the bucket. As I said before, the water flow out from the jet will split into half and form an angle, which is we call as a beta, and the velocity of the water is actually moved to the right, but we can still get the velocity of the jet and the velocity of the bucket from the equation that have given. Okay, and then also from the theory we can know the maximum power that we receive on the Pelton turbine when it rotates on omega velocity of the jet and the length and the radius of the jet. Then we also can analyze that the bucket what is the speed of the water jet coming out. Okay, that's all. Thank you.
Thank you, Bad. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nur Imam Balkis binti Syamsul Kamar and my matrix number is ME19235. Today, I'm going to present the chapter 3 for Pelton wheel experiment. I will going to explain about the methodology, or in other words, it's called the procedure. I will start the presentation. The main apparatus that are being used in this experiment is Pelton wheel turbine and hydraulic bench. Pelton wheel turbine consists of pressure gauge, spear valve, spring balances, tachometer, and turbine. While hydraulic bench consists of drain pipe, drain valve, wet bin, and measuring tank. Now I will continue with the procedure. First, I will explain the setup for the procedure first. The first step is close both the spear valve on the Pelton wheel turbine and the valve on the hydraulic bench. Secondly, make sure to release tension in the cord connecting the spring balances. Third, adjust the screws at the top of the spring balances until the cord hangs loosely from the hooks. Then, note any offset in the force readings. Lastly, remove the drain column from the drain and set it aside. Now, we can proceed with the experiment. The first step, turn on the pump in the hydraulic bench and then fully open the bench valve. Open slowly the spare valve until it is fully open. After that, record the pressure reading from the pressure gauge. Then, increase the load of the shaft by increasing the tension of the spring balances. The fifth step, you have to adjust the screw above both spring balances until the rotational speed slows to approximately. Then, the tachometer should be aimed at the path of the white square just off center of the hub. The tachometer reading will slightly in time, so estimate the average rotational speed over the course of a few seconds. Then, record both forces indicated on the spring balance. After that, record the forces on the spring balances at each speed. The 10th step, plugging up the drain at the bottom of the bench with drain column. You have to make sure the rubber gasket is placed between drain column and the drain. After finish recording the flow rate, remove the drain column and set it aside. Don't forget to reduce the flow rate by closing the spill valve completely and then reopening it only 2 turns. Now, I will explain the process of shutdown of the machine. Firstly, pull out the water from the drain column, then close the spill valve. After that, close the flow control valve on the hydraulic bench and turn off the pump. Release the pressure in the feed line by briefly opening the spill valve. Don't forget to adjust the screw at the top of the spring balances to release the tension. Lastly, last for all the procedure, carefully pour the water out of drain column and place it back into the drain. That is end of my presentation. I will pass to Mira and Hani to continue with the presentation. That's all from me. Thank you.
So hello, my name is Hani Bernarduni and I'm Winston Rajit with the metric numbers of MA19245. So today I'll be presenting on the results for this lab 5. So first we have turbine characteristic curve, and there's a fully open constant at 0.2 bar and constant Q at 30.9 L per minute. So here's the data that has been provided, which is first of all we have rotational speed, and then moment on the shaft, power out, power in, and lastly is efficiency. So next we have power curves, pressure at 0.2 bar, Q equal to 18.75 L per minute. So we also provided with a rotational speed and power out. So from this data we can obtain a graph. So there's a graph for moment versus rotational speed, power out versus rotational speed, and lastly is the efficiency versus rotational speed. So the moment versus rotational speed can be obtained from the first data, which is this, the moment versus the rotational speed, and then the power out versus rotational speed can be obtained also from this data. And lastly, for efficiency versus rotational speed, you can obtain it from data here. Rotational speed versus efficiency. Efficiency versus rotational speed. Yes, that's all from me. Thank you.
Assalamualaikum. My name is Nurul Amira binti Muhammad Nasir. Metric ID is MA19291. For this lab 5 Pelton wheel turbine, I will explain my part in this lab, that is discussion from chapter 4. Okay, first question is measured data. Measured data is mean by data get by measuring something using measuring method. Can be obtained the result using apparatus or after experiment, whether it manual experiment or measuring by hand, that is measured data. Okay, we consider the measured data is not too accurate than calculated data because there is no justification or solid type of measure data. Maybe error occur when we conduct the measurement. Okay, for calculated data, we get data by using calculator and formula. We're using scientific calculation based on theory and formula. And this type of data will be more promising and precisely accurate because we use formula and scientific calculation. So there is more solid in that way. Question number 2, how pattern wheel works. In year 1870, this type of turbine was invented by Lester Allen, an American inventor. Pattern wheel is an impulse turbine where static pressure head of water convert to mechanical energy. Pattern wheel works by collecting the impulse of energy from the moving water, which push against the water weight. For question number 3, what factors that affect efficiency of Pelton turbine? First, the type of material used to build the turbine system. Different material, different efficiency based on weight and shape. Second, design of water jet. Third, control of water jet movement. And last, control of water flow rate that will affect the efficiency of the turbine. There are many factor, but I choose to come with the 4 factors. Question number 4, why is the efficiency low? There is many reason why the efficiency might be low, but I choose 1 because there are erosion at the splitters and cutout. This also can lead the outcome to experience reduction in turbine efficiency. For question number 5, what is maximum power output that can be produced by this Pelton turbine? Okay, the maximum power output can be produced by Pelton wheel is around 20 megawatt. The small Pelton wheel. Pelton wheel have various of sizes. So if the size bigger, it will produce more maximum output and can up to tens of megawatt. That is 10 times 10 power of 9 in Pelton wheel, which plays in larger scale. And last question for question number 6, how to increase the efficiency outcome. First, make sure the jet hit the center of the Pelton bucket accurately. Second, to minimize the losses, the bucket must be accurately designed. And third, to get more power through a single Pelton rotor, we can use multiple spare jets to a maximum quantity. We use lot of amount of spare jet, and with maximum number of jet, the Pelton turbine casing working at full power. That's all from me. Thank you.
Okay, lastly, for the conclusion, from this investigation that we have carried out, it is capable level of accuracy. The experiment had to decide the properties of the machine. From the all-over experiment, we know the properties of the turbine and the characteristic of the operational in the system. The different range of flow rate and rotational speed influence the performance of Pelton wheel turbine. The combination of flow rate and jet velocity manipulates the power of work input. The bigger the diameter nozzle, the faster the flow rate, but lower in velocity jet. In general, impulse turbine is high head, low flow rate. So we can assume the experiment is successful due to the result obtained. That's all. Thank you.